Good day to all my viewers around the world. Once again, you're welcome to my YouTube channel. Today, we'll still be looking at Nigerian Mathematics Olympiad, first round for senior category. But before we go into the question, please don't forget to subscribe, share, like, and comment. Thank you. All right. The question we have here is for senior category. And the question is simplify 2 raised to the power of 2020 modulo 625. We have the option A to be 1, option B to be 32, option C to be 316, option D to be 145, and option E to be 451. Okay, the question is very simple. So how do we go about this? Let's look at the solution to the question. Solution. Okay, for this question, the first thing we need to do is we need to take a look at Euler's generalization of Fermat-Little theorem. That's what we're going to look at. And while looking at that, we need to take note of something that 2 and 625, they are coprime, okay? So we have from Euler's generalization of Fermat's little theory or theorem. Okay. So we're going to adopt this Euler generalization of Fermat theorem. And from the question, we have 2 here and we have 625. That means 2 and 625 are coprime. Okay. And the first question we're going to ask ourselves is, what is coprime? Okay. Coprime are numbers that share no common factor other than 1. They share no common factor other than what? Other than 1. That's the meaning of coprime. Okay. The Fermat theorem is now stating that if we have 2 raised to the power of 500, it is congruent to 1 mode 625, using what we have from the question 2 and 625. Like I said, 2 and 625, they are coprime. So if they are coprime, then 2 raised to the power of 500 is congruent to 1 mode 625, using the Euler's generalization of Fermat's little theorem. And if we proceed from that, the question we're given is 2 raised to the power of 2020, okay? Then we have it in modulo 625. So how do we project this or how do we solve this further? So let's solve this by writing it this way. We have 1020, which can also be written as 2 raised to the power of 500, okay? Close the bracket. Then we have raised to the power of 4, then times 2 raised to the power of 20. We all have the idea of indices here, okay? Remember, in indices, when you have a raised to the power of x times a raised to the power of y, it gives the value of a raised to the power of x plus y. Also, one of the laws of indices states that when you have a raised to the power of x, okay, close bracket, also raised to the power of y. This is what we call double power. It gives you a raised to the power of what? Xy. So this is double power here. If you multiply this one, you're going to get 2 raised to the power of 2000. And since they have the same base, 2 raised to the power of 2000 times 2 raised to the power of 20 gives you 2 raised to the power of 2020. So we simplify 2020 down using indices. And don't forget, we're dealing with modulo 625. So in bracket here, we have modulo 625. Okay, so from what we have here now, let's proceed. Now, from the theorem we stated earlier on here, we said 2 raised to the power of 500 is congruent to 1 mod 625, okay? That means 2 raised to the power of 500 here is 1, which is raised to the power of 4, the 4 we have here, then times 2 raised to the power of 20. Then we still have our modulo 625, okay? So, of course, 1 raised to the power. Of course, from here, we have 1 raised to the power of 4 will give us 1, then times 2 raised to the power of 20 into bracket of modulo 625. Okay, so from here, 1 times 2 raised to the power of 20 will give us 2 raised to the power of 20, and we have modulo 625. And from here, I can break 2 raised to the power of 20, and I can break it down just in form of indices to have a double power 2. That becomes 2 raised to the power of 4, okay? Or 2 raised to the power of 4 into bracket of the power of 5, okay? Then I still have my modulo 625. Okay, so from here, permit me to clean this. So from here now, what do we have here? So 2 raised to the power of 4, that's 2 times 2 times 2 times 2, that's 16, okay? We have 16 raised to the power of 5, okay? Then we have into bracket of modulo 625. Okay, now on getting to this part now, let's try and get the value of 16 raised to the power of 5. 16 raised to the power of 5 give us 1048, 1048, 576. 576, so we have it in modulo 625. Okay, so from what we have here now, all we need to do, we're getting closer to our final answer. We use 1048,576 to divide 625. So dividing that, we have 1048,576 divided by 625. So this is actually going to give us 1677. Then we have remainder of 451. Okay, remainder of 451. So if we have the remainder of 451, so how do we go with this? So in a nutshell, we have 2 raised to the power of 2020, okay, is congruent to the remainder is this 451, 451, and the mode is, we have modulo 625. So from the final answer that we have here now, we have 451 as the remainder, okay? And looking at the options that we have, that is option E. So the answer is option E, okay, which is 451. So we have come to the end of today's class. I hope you enjoyed this class, but don't forget to subscribe, like, share, and comment. See you next class. Thank you.